In today's video, the calculations we're going to be doing all revolve around electricity and electric charge. So we'll be calculating things for current, for power, and then also for resistance. Here are some units we are going to be using throughout these calculations. If you're not familiar with these, now's a great time to pause the video, look over these, make sure you understand where they're coming from. If not, refer back to your notes. For our first calculations today, we're going to be looking at Ohm's law, which is voltage equals current times resistance. And ohm that's how you pronounce OHM. Ohm, it's of course going to be based off of a Greek letter. Usually we can have the symbol for omega for ohms. This is going to be, again, voltage equals current times resistance. So in terms of voltage, we have this V voltage. The I stands for current, and current is in terms of amperes or amps, and the unit's going to be a capital A. And lastly, we have resistance. And resistance is going to be our ohm, or our omega symbol. Our first problem here, a 1.5 battery is connected to a small light bulb that has a resistance of 3.5 ohms. What is the current in the bulb? So we're going to be using Ohm's law to solve this. So VIR. We have voltage. It gives us a voltage of 1.5 volts. It's asking for the current. Remember that I stands for current. And lastly, it gives us a resistance of 3.5 ohms. Now, in terms of solving this equation, we have V equals IR. We need to get I on a side by itself because we're solving for the current or amps. So we're going to divide both sides by R. So that gives us I equals, our R's cancel out, V over R. For this, we have to make sure everything's in the right unit, and it is volts for voltage and then ohms or omega for resistance. So we're going to plug in 1.5 volts divided by 3.5 ohms. This is going to give us a value of 0.428. Our unit for current is amps, so that's going to be a capital A. For our next problem, the current in a resistor is 0.50 amps when connected across a voltage of 120 volts. What is the resistance of the resistor? So we will be solving for ohms in this case. V equals IR is our formula. The voltage is 120 volts. It gives us amps or a current of 0.50 amps, and we're asked to solve for resistance. So here we need to get resistance on a side by itself. We're going to divide both sides by I. I cancels out. That leaves us with a formula of resistance equals voltage over current. That's going to be 120 volts divided by 0.5 amps, which gives us a value of 240. In terms of our units, the units for resistance is going to be ohm. So that's the Greek letter omega. This would be our answer for this one. For this slide, we're talking about power. So power equals current times voltage. For power, our units for power are going to be watts, which we previously learned in, I think about 2 chapters ago. And then remember, I is amps or current. And then lastly, V is going to be volt or voltage. And voltage also talks about the potential difference. So remember, when a question may ask you for the potential difference, it's also asking for volts. Here we have a hairdryer that is plugged into a 120 volt outlet. The hairdryer has a current of 9.1 amps. What is the hairdryer's power rating? So this is very relatable. When we buy appliances or even something small like a hairdryer, it always has a power rating on it. And so this is how they actually calculate that power rating. Again, we have our variables here. It's asking us to solve for the power rating. In terms of the current, it gives us 9.1 amps, and we are plugged into a 120 volt outlet. All of our units are in the correct format here. We don't have to do any unit conversions. So this is going to be simply current times voltage, P equals IV, where I is 9.1 amps and the voltage is 120 volts. We plug this value into our calculator and we get 1092. Our unit for power is going to be watts, capital W. There we go. Or in some cases, more commonly found on appliances, this would also be equal to 1.092 kilowatts. So either one of these are, of course, going to be the same thing. So, unless the question specifies, which it should when you're working problems out, whether it wants it in watts or kilowatts. But there are your answers for that. And of course, we can do other ones where we rearrange this equation. So in this case, this is where we're solving for power. If you're solving for current, current is going to equal power over voltage. If you're solving for voltage, voltage is going to equal power over current. So there's your other two variations of this formula in case you need it. For this last problem, we can sometimes combine these two equations, which may be asked of you. So here we have a hairdryer again that's still plugged into a 120 volt outlet, and it has a power of 850 watts. It wants to know what the hairdryer's resistance is. So when we look at our two formulas that we have here up top, only one of these formulas has the variable for resistance, and that's going to be V equals IR. So ultimately, we're going to have to use this equation to solve for resistance. So voltage, current, and resistance, where resistance gets the question mark, it gives us the information of 120 volts. And then it gives us a power. It doesn't give us a current. Okay, so we need to know that current in order to solve for R. So the question becomes, well, how can we get that current? Well, given that we know let me write this in a different color down here. Let's write down the variables that we know. So again, we know the voltage. We have 120 volts, and it also gives us power, which is 850 watts. So we have a P and we have a V. Again, what we need to solve here is an I. What you have to ask yourself, is there an equation that relates all three of these terms? And of course, our answer is going to be yes. This is P equals IV. If we're able to solve for I out of this equation, we can plug it back into V equals IR. So let's do that here real quick. So we have P equals IV. We need to rearrange this to where I is on a side by itself. So that is going to give you I equals power over voltage. All of our units are in the correct format. That's 850 watts divided by 120 volts. That is going to give us a value of 7.08. Our unit for current is amps, or capital A. Now we can take this number and we can plug it back up into here for the I value, for our amp value. So 7.08 amps. Now we know the two variables that we need to solve for resistance. We have V equals IR. We need to rearrange this to get R on a side by itself. So we're going to divide both sides by I. That's going to cancel out, and it's going to leave us with a formula of resistance equals voltage over current. We have 120 volts divided by a current of 7.08 amps. Plug this into our calculator, 120 divided by 7.08, and it's going to give us a value of 16.95, which we can kind of just round up here and say 17.0. Our units for resistance, whoops, kind of got a little carried away there. Let's see if we can fix that. Oh, it's not wanting to erase very well. No worries, we can kind of just scratch that out. 17.0 ohms. So in this case, again, we have to use a combination of the equations to really get what we're solving for. So this is how you would potentially do that. And again, different variables can be missing. Always when you're solving problems, write down what formula you know you have to use in the end. Then write down what you're given. Based on what you're given, what can you solve for, and kind of work through problems that way. I feel like most of these are pretty straightforward. However, if you have any questions, as always, please send me an email. Let me know. I will be more than happy to help.